To proceed the chapter laws of motion, we were discussing the questions, exercise questions. The question number 5.19. A shell of mass 0.02, a shell of mass 0.02 kg, mass of the cell, mass of the cell is 0.02 kg. Mass of the cell M is 0.02 kg. Is fired by a gun of mass. The mass of the gun. Mass of the gun. Suppose capital N is the mass of the gun, which is 100 kg. If the speed of the cell is 80 meter per second, speed of cell 80 meter per second, then what is the recoil speed of the gun? We have to find the speed of the gun. Recoil speed. Recoil speed means the speed by which the gun exerts a force in backward direction. So recoil speed of gun we have to calculate, and let the recoil speed of the gun is capital V. So according to the law of conservation of momentum, according to the law of conservation of momentum, total momentum before firing, total momentum before firing is equals to total momentum after firing. So before firing, gun and shell both are in rest. So before firing the total momentum is 0, and after firing the total momentum means momentum of shell plus momentum of gun. So mass of gun is m and velocity of gun is v, plus mass of the shell is a small m and the mass of the velocity of the shell is a small v. So m into v equals to minus m into v, and v equals to minus m upon m into a small v. Now we put the values. So the value of a small m 0.02 upon 100 into 80. We remove the decimal. So 1 0 gets cancelled, and 8 into 2, 16 upon 1000. 16 upon 1000, which is 0.016 minus 0.016 meter per second. Minus sign shows the recoil speed. The gun exerts a force in backward direction. So minus sign shows the recoil speed, and the velocity is 0.016 meter per second. Next question, question number 5.2. Question number 5.20. A batsman deflects a ball by an angle of 45 degree. A batsman deflects a ball by an angle of 45 degree. This is the ground and O is the position of the batsman. And this is the vertical line. Name it L. O is the position of the batsman. Ball comes to the bat and the batsman deflects the ball at an angle of 45 degree in the same direction. So this whole angle is 45. It means the half angle is 22.5 and this angle is also 22.5 degree. So a batsman deflects a ball by an angle of 45 degree without changing its initial speed, which is equals to 54 kilometer per hour. The initial speed of the ball is given 54 kilometer per hour. So firstly we convert it into meter per second. 54 into 1000 divided by 60 into 60. And that is 15 meter per second. This is the speed of the ball. And a batsman deflects the ball without changing its initial speed, which is equals to this. What is the impulse imparted to the ball? And mass of the ball is given 0.15 kg. Mass of the ball is 0.15 kg. So we have to find the impulse imparted on the ball, and impulse equals to change in momentum. Impulse is equals to change in momentum. So first we calculate initial momentum of the ball. Initial momentum of the ball. Initial momentum of the ball. Velocity is inclined at an angle of 22.5 degree with the vertical. So there must be two components. One is horizontal component, which is V cos 22.5 degree, and another is vertical component, which is V sine 22.5, and that is V cos 22.5 degree. V is inclined at an angle of 22.5 degree with the vertical, so it must have two components, horizontal component and vertical component. And the direction of this component is along NO, and along NO direction we have taken as positive direction. Along NO direction is taken is positive. And when it deflects by the same angle, means by the vertical, the angle is 22.5, then the direction of velocity is along ON. So the direction of velocity along ON would be taken as negative. So when it deflects at an angle of 22.5 degree with the vertical, so again there must be two components. One is V sine 22.5 degree, and the vertical component V cos 22.5 degree. So both have the opposite direction. Both have the opposite direction and they have V sine 22.5, V sine 22.5. They are in opposite direction and same magnitude, so they gets cancelled. Both the components gets cancelled. So total initial momentum of the ball is equals to mass into velocity. So mv cos 22.5 degree, and along OA, along NO. We have taken positive because along NO direction there is positive plus. This is the initial momentum of the ball. Now final momentum of the ball. Final momentum of the ball. So the velocity direction of component of velocity along ON, and along ON it is taken as negative. So minus mv cos 22.5 degree along ON direction. Now impulse equals to change in momentum. Change in momentum. So final momentum minus initial momentum. Final momentum is minus mv cos 22.5 minus initial momentum is mv cos 22.5 degree, and that is minus 2 mv cos 22.5 degree. Now we put the value of m and v. Mass is 0.15, velocity is 15 into cos 22.5 degree. Minus 2 into 0.15 into 15, and the value is cos 22.5 minus 30 into 0.15, and the value of cos 22.5 is 0.9239. 0.9239, and when we multiply it, we get the result 4.16 kg meter per second. So this is the impulse, which is equals to change in momentum, means final momentum minus initial momentum. Now question number 5.21. A stone of mass 0.25 kg tied to the end of a string, which is wheeled around in a circle of radius 1.5 meter. So the mass of a stone is 0.25 kg. Mass of the stone is 0.25 kg, which is tied to the end of a string, which is built around a circle of radius 1.5 meter. Radius of the circle is given 1.5 meter with a speed of 40 revolution per minute in a horizontal plane. Means frequency is given. Frequency is F is 40 revolution per minute. So we convert this into revolution per second. 40 upon 60 revolution per second. means frequency is 2 by 3 revolution per second. F is 2 by 3 revolution per second. So what is the tension in the string? So for finding the tension, we will have to calculate the angular frequency. Omega is equals to 2 pi f, 2 into 3.14 into the value of f. F is the frequency, which is 2 by 3. And after solving, we get 4.19. Omega, the value of omega 4.19. And the unit is radian per second. 4.19 radian per second. Now we have to find the tension. So formula for tension is mv square by r. We have derived the result mv square by r, but v equals to omega into r. So m omega r square upon r means m omega square upon r. 1 times r gets cancelled. So m into omega square into r. The value of mass 0.25, omega 4.19, the whole square, and the radius is 1.5 meter. And after solving, we get 6.6 Newton. The value is 6.6 Newton. This is the tension produced in the string. Then we have to calculate if what is the maximum speed with which the stone can be built. If the stone withstand a maximum tension is also given. T maximum is given. Now this was the first part. For second part, we have given T maximum 200 Newton. And we have to calculate the maximum velocity. The maximum velocity by which the stone can be built, so that it exerts a tension of maximum tension 200 Newton. So the formula for T maximum equals to mv maximum square upon r, and we eliminate the value of v maximum. So v maximum square equals to T maximum into r upon m, and v maximum equals to under root of T maximum into r upon m. So square root, the value of T maximum is 200, r is 1.5, and small m is 0.25. And after solving, we get 34.64 meter per second. 34.64 meter per second. This is the maximum speed by which the stone is built to complete a horizontal cycle. Question number 5.22. 5.22. If in question number 5.21 the speed of the stone is increased beyond the maximum permissible value. In the previous question, if the speed of the stone is increased beyond the maximum permissible value and the string breaks suddenly, then which of the following correctly describe the projectile of the stone after the string breaks? So in this question we have given that in previous question, If the speed of the stone is increased beyond the permissible value and suddenly the string breaks, then the path followed by the stone, the projectile, the path followed by the stone. So the direction of velocity in the circular motion is tangential path. The direction of velocity in the circular motion, the direction of velocity in the circular motion is tangential. The direction of velocity in the circular motion is tangential. So as the string breaks, the stone flies off tangentially. So as the string breaks, the stone flies tangentially. The stone flies tangentially. So the correct option is B. B is the correct option. The stone flies tangentially. And question number 5.23. This is the explain why reason. So already we have discussed this question in theory part. So we have completed this chapter. Then we start in the next video, work, energy and power.